Yeah.
I'm going to, because I'm a Jason.
That's necessary.
Yeah, he's that's the man Armyworm. Like Obi-Wan Kenobi.
Just to obey everything I said.
Obey?
Okay. Because I
Oh, yeah, that's
all right.
Do you want to take a look at it?
Welcome to the Genetic Engineering and Society Colloquium. I see some new faces in the room. Welcome. My name is Jason Delborn. I'm one of the faculty in GES and also in the Forestry and Environmental Resources Department. And I'm coordinating the colloquium this semester. We always start just with any upcoming announcements of GES-related events. Anything coming up in the next couple weeks? Fred?
Yeah, so Friday, well, let me back up. Bob Patterson, who many of you know, this is his 51st year at NC State. And there's something on the website of, you know, Cal's website with him giving a little talk. But he's going to give a talk on Friday in Williams Hall at 2 o'clock. So if any of you, Williams Hall, 240.
No, this Friday?
This Friday,
okay.
the 19th, yeah. So if we'll try to send that sometime.
That's fantastic. Anything else? Yeah, Eli.
Pathogens is on Saturday, to the extent that that applies.
And how could people get involved? Where's it happening?
Oh, it's at the Museum of Natural Science downtown. I don't know that they've yet had a gene drive exhibit, but if you're at all interested in insect topics,
Cool.
it's the place to be.
Okay. Anything else? And just as a heads up, next week during colloquium, we're going to have a chance to talk about a recent award that was won from the National Science Foundation, a national research traineeship that we're calling Ag BioFuse, which stands for Agricultural Biotechnology in our Evolving Food, that's the F, Energy, that's the E, and Water Systems, that's the W. So Ag BioFuse. It's a new graduate program. We'll be recruiting cohorts of PhD students, much like the GES IGRIP program did in the past. And Fred is going to lead us in a discussion about the kinds of plans and programs we have for the upcoming years. Lots of interesting work to do for faculty and students to be involved. Anything else you want to add to that?
No, just so we need everybody's help.
Yeah. And I will pass around this sign-up sheet. If you're you've already signed up on this, you don't have to write your email, but otherwise please fill this out so we know that you're here. And I'll turn it over to Fred to introduce our speaker for today.
All right, so it's a great pleasure for me to have Allan here. Some of you know Allan because Allan was on the Mexico course. So all of you folks who were on the Mexico course interacted with him. And also he was at one of our gene drive workshops. So he's been involved here pretty recently. But Allan and I go very far back, farther than we would almost like to admit. But Allan got his bachelor's degree at Michigan, then a master's at Duke, and then he actually got his PhD here. And maybe sort of under my tutelage, but actually he came here with his project almost finished, and he needed a year to write it up, and somebody had to sign the papers. So basically, I have to say that. So, but very interestingly, Allan has been working in Latin America for his whole career, and even his PhD was there. He worked actually with the Sandinista government to do an integrated pest management on fall armyworm as his PhD thesis, and he has papers to prove it. So, but he started out with that, and after his PhD, he continued to work in Latin America. I mean, I can name off some of the things, but he was the head of the Department of Plant Protection at Zamorano University in Honduras, which has been considered one of the premier agricultural schools in Latin America. He worked in Nicaragua. He worked in Chile with FAO. He has an organic plantation or small farm in Nicaragua. He's done all of these things in Latin America. And then working with FAO, all of a sudden at one point the hook came and they pulled him over to Rome a couple of years ago to work in the main office or whatever. And then all of a sudden his favorite pest moves from the Western Hemisphere to Africa and becomes this big issue. And there couldn't have been anyone more pre-adapted to working on this system. And so Allan has taken on leadership in that, and that's really what he's going to talk to you about today. So I'll let him get going on this.
Thanks very much, Fred and Jason and Jennifer and the Center for inviting me to come here and speak today. I guess I'll stand here to move the slides. So first I want to apologize because I'm going to go too fast, because at first I thought I had 45 minutes to speak and then I'd cut down the slides, but there's still, as always, too much you want to say in too short of time. So if I get going too fast, just slow me down, please. I have a tendency to speak way too fast. But the fall armyworm, so as Fred just described, moved from the Americas, it's here in North Carolina every summer, but it moved from subtropical, tropical Americas to Africa, West Central Africa, at least 2 years ago. Could have been there a few years earlier and unreported, but first reported officially in early 2016. As many of you already know, fall armyworm is Spodoptera frugiperda. It's a noctuid. It's very, very prolificous, which is an important part of the story. Feeds on many, many plants, not just crops, but over 80 crop species. So it can feed on many important crop species, including maize, corn, rice, sorghum, millet, etc. So if you look at this high-tech animation here on the right, you can see how it moved very quickly, reported officially by the countries in green, and then detected but finally reported later in yellow. Since January 2018, it's actually continued to move. It's certainly gotten to Eritrea, confirmed in Sudan. It's jumped across the Gulf into Yemen, and 2 months ago reported in India also. So it's continuing to spread geographically. So, and it will continue to spread. Just a little map of suitability areas in the world. And this is really concerning here, Southeast Asia. It'll probably move from India and Southeast Asia into China. China is the #2 maize or corn producer in the world, of course. Many smallholders, as in Africa. And then, of course, how did it get to Africa? Everybody asks me. We don't know, but certainly there's so much globalization of goods and people that it's actually surprising that we don't have more cases of the movement of such pests and diseases in the world today. Just massive, hard to control movement of goods and services, or goods and people. What kind of impacts fall armyworm potentially have in Africa? And I'm going to concentrate the whole talk on Sub-Saharan Africa. That's what we've been working on for the last couple of years, even though it's now moved on. And also just maize. And again, it moves on big time pests in sorghum, millet, etc., even rice. But maize has been a great concern, so my whole talk will be about maize in Sub-Saharan Africa. So some estimates about what the yield loss is potentially to fall armyworm in Sub-Saharan Africa. We use 10 to 20% yield reduction, which is sort of a moderate range, but a realistic range of yield reduction from fall armyworm infestation. Look at the total maize production in Africa, which is about 40 million hectares per year at a certain production rate, is 8 to 16 million tons per year, an estimated cost of $2.4 to $4.8 billion per year, which is very significant in the African context, globally, but especially in the African context. But even more concerning than the numbers, the lost production, the value of that production, is really the impact on livelihoods. The vast majority of maize produced in Africa is produced by smallholder farmers, typically growing less than 2 hectares. So the maize production is used for self-consumption, family consumption, so any of this loss of production really directly affects the potential food insecurity of these households. So I don't have time to go into this, what I cut out of my presentation, sort of FAO's program and presentation of what we've done as FAO in how to construct a program, basically a task force. If Fred was right, when it arrived to Africa, they asked me to coordinate our response. But I worked very much with many colleagues in FAO headquarters. Some of the work will be described here. And also many of the colleagues across Africa. We have regional offices, sub-regional offices, and offices in every country. But we also work with many partners, not just FAO alone, but we try to work with many CG centers, CIMMYT, IITA, other international centers in Africa like ICIPE, CABI, as well as the national programs. So we've constructed a partnership, a global partnership, whereby FAO and many partners try to help the member countries and finally those farmers, those tens of millions of smallholder farmers, have an adequate response management program for fall armyworm. One of the things we did do, and it's of interest to many universities and researchers, is that one of the things we typically do and did do for fall armyworm, one of the things that UN, we always do as the UN, is we create technical working groups or expert groups. And we have done this around fall armyworm specifically. We helped create 12 of these such groups, which bring together experts from around the world who join virtually. We don't have money to bring people together, but we have virtual meetings to discuss what is the current science-based state-of-the-art of management from places like Brazil, the US, Mexico for fall armyworm, as well as working with African partners so that they quickly learn about the science, the evidence, the experiences from other parts of the world to create kind of an agenda for both practice, but especially research in Africa. So that's these 12 technical working groups. And if any of you have any special interest in participating in such a group, please let me know, because we're always looking for experts who would like to be actively engaged in these kinds of processes. But so that was really quick about the fall armyworm, the FAO program response. But I really want to talk about the real problem and what we're doing now, not just us, but all partners in Africa. So first, when fall armyworm arrived in Africa, it's created this charismatic damage that many of you are very familiar with. But for African farmers and ministers of agriculture, this is a really alarming type of damage, because this type of damage, foliar damage, severe damage of the leaves, basically is unknown in maize previously. Although they have other insect pests, the stem borers, etc., basically unseen. So this is very new type of damage that, except for the African armyworm, which is very sporadic. Something else is another armyworm, but it's not consistently in the fields. It has boom and bust cycles based on rainfall and other drivers. But for the first time, farmers have seen this type of damage and been very alarmed. And that alarm, their concern, quickly arises to other levels, up to ministers of agriculture, and they look for a quick response. So unfortunately, the response, very quickly, a couple of years ago, the first years of it arriving, has been government officials, ministers, or local district commissioners at a level, look for insecticides to quickly buy and give away to the farmers to apply for fall armyworm. I say unfortunate because there are a couple of problems with this approach, this unilateral approach, let's say. One certainly is that sometimes the chemicals that have been purchased either by governments with their own money or by donors, USAID, World Bank, African Development Bank, European Union, etc., has been to procure pesticides which are truly represent human health hazards to the people who use them. For example, and some of you are aware of the kind of compounds out there, but one country, I'm not going to name names, continues to give away carbosulfan, which is a very toxic pesticide. Another couple countries continue to give away endosulfan. Carbosulfan was deauthorized by the European Commission for known human health hazard reasons 10 years ago. And endosulfan, I think, has been banned in the United States for use, again, for human health reasons. So one problem certainly is that these older molecules, which are available in Africa, generics produced elsewhere, are widely available and cheap, but the response has been to procure pesticides, many of them being these hazardous pesticides, and give them smallholders. But the other part of the equation that is why this is concerning is that this is not even sustainable, economically sustainable. Smallholder farmers in Africa do not use many pesticides in their maize production. In fact, very little, if none. Some countries have subsidy programs, and there's a little bit more pesticide use. But I'll give you some figures from a couple of countries, and these household surveys done by the World Bank. In Malawi, 3% of the farmers use pesticides in their crops. And in Namibia, the recent study that we did in FAO, of smallholders in Namibia, 1.7% of the farmers use pesticides. And why don't they use pesticides? It's not because they don't know about it or they're not available. Pesticides are available in Africa. It's because it doesn't make economic sense to them. Again, these farmers are growing maize for self-consumption, not really for sale mostly. There's some variation in countries, but for the most part, it's for their own use. And if they do sell any maize, it has very low value. Okay? So again, to belabor the point about the types of farmers, here's a graph of the size of farmers' fields around the world. And of course, we know in the Midwest, in this Caribbean area, in Brazil, or in parts of Europe, we see large farms, which are the purple colors. Africa, basically only South Africa has some large commercial farmers. There are a few here and there in Namibia and Sudan, but little points. Most of the color here are these very small farms, which are less than 2 hectares. And many of them are less than a hectare or half a hectare. So very small fields, very heterogeneous area. We can talk about that a little bit. But basically, I want to talk about the farmers. At the end of the day, the response to the fall armyworm, governments can give away pesticides for a year or two, but that quickly runs out. They run out of money, or the donors get fatigued about doing that. There's pushback from their capitals. That's not going to last for long. In fact, we've already seen signs that that's ending. So what are the farmers going to be able to do longer term to manage fall armyworm in their fields? Well, this is a typical farmer in Africa, often a woman, very few resources, representing the vast majority, 98% of those farmers, as shown by that graph, of smallholder African, Sub-Saharan African maize farmers are smallholders. Okay, the vast, vast majority. And what do they do? What are their characteristics? As I mentioned, they basically do not use, or very few use pesticides or even fertilizers. They save their own seed. Basically, they're to local consumption. They consume most of it. If they sell anything locally, they sell it for a very low price. To give you an example, in Mozambique recently, we were down there doing some surveys, and the farmers, if you ask the farmers, not the market price that sold the market, but how much the farmers receive, we're talking about 2 cents per kilo for their maize, what they receive. Basically, such low prices that it's very difficult to purchase any inputs, let alone pesticides, for the production, even with fall armyworm. And then finally, of course, they face all the burden of risks. There are no such things as price supports or guarantees for prices. There's no such thing as risk transfer mechanisms. There are no insurance programs for these farmers. So they face and on their shoulders carry all the risks. So one of the pending questions about how do you manage fall armyworm, what decisions you make, what options are available to you, starts with really the question of yield loss. I used 10 to 20% in one graph there, but that is really a question that needs to be answered still in Africa. Most of the damage was, in the first slide I showed, a kind of defoliation. Okay? You can get damage to the meristem, and you can get direct damage into the cob, or to the ear, which obviously is much more serious. You get direct damage, much more concerning. But these are atypical, either meristem damage or into the cob, much more atypical. typical damage of fall armyworm is defoliation of those leaves coming out of the whorl or the funnel. And maize, in fact, has a capacity to tolerate or compensate for a high level of that damage. So we look at that as farmers, first time you see that, are alarmed. But one of the things we're trying to do is to make sure that we don't fall into a panic reaction because of that damage. And in fact, just cite one data point, the Insurance Institute of the United States, which sets the basis for the insurance program for hail, for example, for corn in the United States, has done these defoliation studies many times because they got to know what the premiums are, what the payouts are going to be. And if you defoliate the corn in the United States, it has different genetics, different fertilization, but you can defoliate it 50% defoliation, artificial defoliation, once at 10 leaf stage, once at 15 leaf stage, and you get a yield reduction of about 12 or 13%. Okay, so that's massive defoliation. Nothing that you get from fall armyworm, but again, with different genetics and different conditions. But the point is, maize can compensate or tolerate for quite a bit of indirect damage. But the context that's most important is to, again, go back and think about what the response could be. Certainly farmers in North Carolina or Brazil or Iowa have very high productivity, high input, and have certain technologies available to manage fall armyworm. That's why, in fact, here in the United States, we don't talk too much about fall armyworm anymore because we have GM maize, BT maize, which works pretty well for these types of farmers to control fall armyworm. And that's working in Brazil, and it's working in the United States. There have been problems with resistance, but there are new technologies, there are new proteins that they find and stack and put in the maize, and that results in management of fall armyworm, basically. There are also, if you don't have that, very effective new chemistries, new pesticides, which also work quite well, but they typically are quite expensive. So the point is that this is one context, again, where you have policies and programs that provide price supports, you have insurance programs, and you have other drivers that make this high productivity possible. But these farmers, either in Central America, smallholders, or certainly in Africa, don't have that context at all. So the technology choices, the options available to them are in a much different place, and that's what I want to get to. So those technologies are there, and they certainly control fall armyworm in Africa, if that were possible in the current economic, social context of Africa. But we're not there. Really, we're thinking about short term, what kind of response can we help the countries and farmers respond to? Well, here's one example. And I don't mean to show this slide and talk about this as the solution, but the point is that under different contexts, governments and farmers look for other solutions, other than the GM maize and the very effective pesticides. Ethiopia, 2 years ago, Ethiopia has a quite authoritarian structure, and they decided that a national program for fall armyworm would be to send people to the field to crush egg masses of fall armyworm. And I don't know if you know fall armyworm, but it's actually a pretty good insect to crush the eggs of because they lay these egg masses of about 80 eggs, and you can see them on the leaves of the plants, and you can walk through and you can crush them with your thumb. But they also then hand-picked larvae. And in Ethiopia sent this past year, and I got the report from the Ethiopian government just a month ago, they sent 1.5 million people to the field, and it's represented like by this photo. It's from actually the Ethiopian report, they sent it to me. I took these photos from the report, their PowerPoint. 1.5 million people, and they controlled fall armyworm through this mechanical hand control on 350,000 hectares of maize. And they reported satisfaction with the control. They said we got a good control and a good harvest, so that worked for us. Yeah, the point is not that FAO is recommending that everybody do this. The point is that under different contexts, there are different solutions for different farmers and countries. And that's one that Ethiopia continues to pursue because it works for them. Okay? Yeah?
What type of influence did the government offer for folks to go out there and do this?
They said go ahead and do it. Okay, so what we've been doing, the FAO and other partners, is trying to collect different ideas and experiences, everything from mechanical control, but understanding really going back to Mesoamerica, Central America and southern Mexico, where some of us were together in Cimet and Oaxaca, to look at how those farmers have managed fall armyworm. Because these are smallholders who've been doing it for thousands of years. And fall armyworm may have co-evolved with maize as people selected for create maize out of Teosinte. And that's where it comes from. And these smallholders are not that different from the smallholders in Sub-Saharan Africa in terms of the heterogeneity of their production, the diversity, plant diversity, interspecific diversity, and even the socioeconomic context. So we had an experts meeting that Fred gave a virtual presentation in Ghana 2 years ago, where we brought experts from the Americas, from Mexico, from the US, from Brazil, to Ghana to meet with Ghana experts to talk about those experiences, especially from Central America, from what we call Mesoamerica. And out of that grew several important documents. These are all on the FAO website. You can Google FAO space FAW and find these all. It's kind of unfortunately buried in our terrible website. But they're all there. There's the FAO Fall Armyworm portal. And one of the things that grew out of this was this guide doing farmer field schools. So the approach has been not that we have solutions for farmers, but really their experiences from other parts of the world that farmers can begin to try, and through an approach of working with farmers, learning by doing, go to your field, try these techniques, is the approach that we've been working with many governments to work with farmers, because it's a brand new pest, and we don't really know what works well or not, or under what conditions. Then we produce these other guidance notes, which kind of summarizes the sort of knowledge that we have, and other communication tools that we have on the website to work with governments and farmers. So the farmer field school approach, just one more mention about that. Again, it's not a sort of recommendation. It's to get farmers out to the field to go discover the ecology of fall armyworm in their maize fields, maize cropping systems, and try things and talk about that and see what works best for them. So that's kind of the evidence base that we're collecting right now in terms of whether or not farmers are satisfied with what the approaches are. That's the website portal I mentioned. You can go find. It has all the documents that we produce. Everything we do in FAO, as the UN system, is available for free. They're all public.
Can I ask a quick question? If
Yeah.
they're working on less than 2 hectares, what room is there for experimentation?
We often create those farmer field school situations where we have a plot of land that we can bring farmers to invite to do it. So they don't have to do it on their own land. We will sometimes support, the government will support a community plot of land to do the experimentation. So some of the key pieces of knowledge that we've come out of, again, drawing on the experience from Central America, as well as what we've been learning the last couple of years, are the following. And I'll go back in some detail about some of these. First, the role of plant diversity, and I'll go in a little bit of detail about that, conscious of the time. The compensation, which I already mentioned, extremely important to talk to farmers and governments about. Farmers' friends, which is the term we use for natural enemies, and I'll talk a little bit more about that. Effective control doesn't have to be fast. One of the results of many years of the chemical pesticide mantras that you've got to spray and see the dead insect, but in fact, if you have a parasitized fall armyworm larva, it's going to be alive. Likewise, if you spray neem on larger instar larvae, it's not going to kill them. It's an anti-feeding behavior. The point is that farmers have to learn that if it's not eating your maize, it's okay. It doesn't have to kill it. And that's an important attitude that many farmers have about spraying something on their crops. And finally, there are many local practices. Farmers around the world, smallholders, try things somewhat out of desperation, but also they think that something might work because they've had some experience with it. And that's what we've been trying to work on in Sub-Saharan Africa. So a quick point about diversity. Diversity is really important for fall armyworm control. In fact, these farmers in Central America, one of the basis of their management of fall armyworm is this traditional system, which is when they plant their maize with the cucurbit, the squash, with the common beans together in a temporally spaced process. This crop diversity can, and it's been shown in papers, published papers, reduce overposition of fall armyworm. There are certain plants that push, and there's in fact, Isipe in Kenya has sort of patented the push-pull technology for for borers, but also for fall armyworm. With the simple idea that you have a plant in your cropping system, your maize-based cropping system, that pushes because of the volatiles of those plants, or a camouflage, so the fall armyworm can't find the maize plant, but the the volatiles of those other plants reduce overposition. And then if you pull them to another plant outside of your cropping system, you can easily control them there. So that's the basic, but diversity, plant diversity is really important, basically to maintain. Most smallholders in Africa plant their maize in a mixed cropping system now. They already have their pumpkins in there, or their cassava, and those plants, some of them are known, in fact, you see they already published a paper, even looking at common beans. Common beans planted with maize reduce overposition by 30% when you plant common beans with maize versus the mountain. So the role of diversity is extremely important. Of course, diversity also can play a very important role in maintaining your natural enemy populations. The parasitoids that need food sources can be there. The predators, generalist predators such as ants, are often in weeds nearby. So the plant diversity not only can reduce overposition, keep them away, but can maintain a good suite of natural enemies in your field. And I'm going to go fast because I'm going to run out of time now. So let's go quickly through that.
Maybe I have another 5 or 6 minutes.
Okay, thanks. So the natural enemies are extremely important, and people say, oh, it's an invasive pest that came from the Americas, so it probably arrived in Africa without its natural enemies. And so we have to do classical biological control. We have to go to the Americas and find those parasitoids, the specialized parasitoids that control fall armyworm in Mesoamerica, but they're not in Africa. That's probably true. There are probably some parasitoids that got left behind. They're still there, they're not in Africa. But the point here is that many of the natural enemies are already there. Okay? So both the generalist predators, earwigs and ants are extremely important in Africa. I don't know why, but I've been in a number of fields now, and I've seen, just by walking through a field for half an hour, ants pulling fall armyworm larvae, a third or fourth out of the plants. Certainly earwigs are important in many parts of the world. The generalist, the specialized parasitoids are also present, some of them, and I'll just show you that. And finally, the pathogens are also already present. The bacteria, the fungi, and the virus that kill fall armyworm naturally. In natural settings in the Americas, this suite of natural enemies can do a pretty good job of controlling fall armyworm if you don't disrupt them. So, for example, in organic sweet corn production in Florida, Rob Mahar, who some of you know, found 91% parasitism, egg parasitism of the egg parasitoids in sweet corn in Florida. If you simply, in organic production, without using pesticides. And there are other data, such as this one from Africa, where, don't read all that, just look at this 45.3% figure. The point is that this is a larval parasitoid from Ethiopia, Cortesia, Isipe, named after the center. 45% parasitism, larval parasitism in Ethiopia. The point is that the natural enemies are there, and farmers, if they learn about them and protect them, conserve them, can take advantage of their natural control. The fungal pathogen. Fall armyworm was first reported in Yemen, across the Arabian Peninsula from Eritrea, in August, 3 months ago. At the same time, our FAO staff and colleagues from the ministry were sending us photos. They sent me this photo. So, at the same time the fall armyworm was first found in Yemen, we also found cadavers of fall armyworm killed by the fungus. So the point is, again, that some of these natural enemies quickly have moved over from other species, from sister species to fall armyworm, and are there. Which leads us to the point of what action farmers can take to conserve the natural enemies, but also attract them or use them in a proactive way. So some farmers in Central America and also in Africa have trying to attract ants, especially. And I don't know if any of you have worked with ants, but you know one way that people who work on ants attract ants is to use tuna fish. You attract them because they're attracted to this strong sort of protein odors. So there are farmers who are trying something similar by using cooking grease, putting it on lard, cooking grease from the kitchens, or old concoctions of fish soup to attract ants to the maize fields. Okay? I'm not saying these are recommendations, but again, these are farmer innovations that farmers try in other parts of the world. Recycling pathogens, those cadavers you saw, the fungus, or the virus-killed larvae that are naturally occurring in the field. The farmers in Africa are collecting them in a little cup and take them home and grind them up and strain it and take what's strained, which is full of fungal spores and virus particles that are bioinsecticides that kill fall armyworm, and go back out and put it in the plants that are infested. So these are locally available, low-cost but effective solutions, potentially, that need to be worked on. And finally, there are other local solutions. Farmers like to try to put all kinds of concoctions in the infested maize plants. Neem, we know, works. There are a dozen scientific papers published on the use of neem for fall armyworm. Tephrosia, a plant in Africa, is also very effective botanical control. There are many botanical controls that farmers can use locally. And then finally, farmers try all these other things: soil, ash, sand, lime, salt, soaps, oils, around the world to try to kill fall armyworm. Some of them probably are not very effective, but some of them are. You know, soaps are used for control. And people say soil. What's soil going to do to fall armyworm? But in fact, there's a study done in Brazil by Fernando Valicente, who looked at soil samples from 1,200 areas in Brazil, in maize fields, in cornfields. It took them 75% of the soil samples had Bacillus thuringiensis in it. Another study in Mexico, 40% of the soil samples in maize fields had the virus that kills the fall armyworm in the soil samples. So it's not just little particles of minerals you're putting in there, but there are certainly pathogens as well that could have an important role in controlling fall armyworm. Okay, so, but these things need to be tested. And here's where sort of a plea to the scientific community and researchers. The point is, these things often don't get any airtime. There's very little funding for this type of work, no interest, even at the level of the national research organizations. They'll say, oh, yeah, but the donor only wanted to fund the pesticide trials, which happened in Malawi, where they developed a research agenda, but the World Bank that was going to fund the work only funded the pesticide trials. But these sort of agroecological approaches have a real basis, a real interesting ecological basis, and they need to be further studied. So that's sort of my plea for researchers and looking for assistance in terms of doing the research at an international, but certainly at a national level. And then to steal 2 more minutes, I want to talk about a different chapter. Some of you interested in this topic. One other thing that we have done in FAO for the program has been to develop the fall armyworm monitoring and early warning system, known as FAMOUS. I didn't make that up, my colleague. Which is a system based on an application for your Android smartphone. We don't have it for Apple yet because that's more expensive, it takes money. But it's on Google Play. It's called FAMOUS, F-A-O. You can go download it to your Android phone and use it. What you use it for is you go to the field, and we have these guidance notes, protocols for taking data in infested fields, and you can go find these guidance notes on our website, into the application. So you put the data in every 10 plants in a row, 5 stations, 50 plants, push the button, and you answer some other questions as you go. You also answer questions about what variety of maize you planted, when you planted it, if you planted in monoculture or in polyculture. Other questions about management practices. Did you spray anything? Did you try any of these practices? So we're getting all that data in the input. You can also input data from the pheromone traps. I didn't talk about that at all, but from base work in the US especially. In Brazil, a lot of work on sex pheromones that we have helped support the country's bucket traps and the pheromone to attract the adults. So likewise, you put all that data in your application, you push it, and of course it's geo-referenced by the GPS in your phone, it goes to a platform, which is something like this. And so at a continental level or at a country level, or you can keep zooming in your Google map down to a district level, you can see hotspots of levels of infestation from the field based on the data that are inputted into the application. And then you can look at all kinds of different analyses across geography, across time, or associate the infestation levels to some of those other parameters you put in the phone. For example, if it's planted in monoculture versus with another crop, an associated crop, you get different infestation levels, which would lead to recommendations for farmers going forward for the next cropping system in terms of how you might plant your plant and when you plant it. And one other thing that we're developing for the application is a digital assistant with Dave Hughes at Penn State University, some of you may know, who's been working with Google and TensorFlow on these new artificial intelligence systems. So first there's a protocol to do the scouting, but this is the cool one. We now have, via the artificial intelligence and face recognition technology, just the way your face is recognized on Facebook, we have developed the recognition of fall armyworm damage. So we can sort of train extension agents and others, is that fall armyworm, by taking your phone and holding the camera up next to the maize plant. You don't have to be offline, and it will tell you with 98% accuracy if that's fall armyworm damage or something else. So it's a way of educating farmers and extension agents about the damage. And then finally, we have a digital assistant, Nuru, where this is still kind of beta in process, but she, Nuru, is a digital assistant, and she will be able to provide interaction to the farmer. In fact, she can even learn different languages. You know, artificial intelligence and machine learning is pretty amazing these days. By training them, you can teach her local languages, so she'll be able to talk to farmers when they go take some data, especially take their data in the field about level of infestation. So if you have high levels of infestation, maybe you should try some of these techniques, and she'll begin to interact with farmers in an interactive way. So it's not just feeding a platform, but also giving some feedback to farmers over time. So that's the summary. You know, fall armyworm is a serious problem in Africa. It's threatening, but we certainly don't want anybody to panic over it, or we don't want to do the wrong things. There's a lot of work left to do in terms of how smallholders can better understand their systems, experiment locally, figure out what works for them. And we also have to work with the national programs and globally with international researchers to help, you know, bring the science, best experience, and best research to help these farmers in Sub-Saharan Africa. So that's where I'll stop, so thank you very much. You can fill your own questions. Okay, so there's questions.
So you mentioned the issue with sort of funding some of these projects. What's the potential of using the little resources that come through the plant treaty to fund these kinds of projects?
That's a good question, and I don't know if I really have a good answer for that good question.
Also knowing that FAO doesn't talk that much about the treaty, you know,
well,
the
that's
same
where,
organization.
That's where I was going to go with the is that the plant treaty is an entity of its own. It's an international convention that sits in the FAO, but we haven't even engaged in that kind of discussion with the treaty to date. They're very much concerned, as you know, about genetic resources and sharing of those and benefits from those resources. And I think they're going to see this as a little far from their mandate, or even what the convention, what the treaty says in its text. So we haven't had a conversation with them. We could, but I suspect that this is going to fall outside.
Well, I was thinking of some of those local even viruses and soil samples and things that would probably fall under the plant treaty. You could maybe make an argument that
Well, that's
that
a great,
falls under their
yeah,
jurisdiction. I mean, it just seems like a serious enough problem that seems like a good use of what those funds are supposed to be for, right?
It's a great point, Pat, and thanks for giving me the idea. I will do that. Go find my colleagues in the treaty and talk to them about it. No, it's a really good point, and I haven't done that yet, so I will. Thanks.
Forgive me if it was mentioned, it wasn't clear to me. Are there, were there other parasites that came over from Central America to Africa with the fall armyworm, and if so, did it present any other problems to the environment of an invasive nature?
So There is one species, an egg parasitoid, Telenomus remus, that has been reported in South Africa that wasn't present in Africa previously, so it apparently did come over somehow. Or maybe it was undetected, maybe it was on other native insects that nobody cared about, has moved on to fall armyworm. But this parasitoid, egg parasitoid, Telenomus remus, which is known from the Americas, has been found in South Africa. So what stories, we don't know. But in terms of it having any damage, I mean, beyond fall armyworm, too new to tell.
Okay.
It does parasitize other species, obviously not just Spodoptera frugiperda, but how broad its host range is, I don't know. But it's something to look at.
Thank you.
Zach or Jason?
You mentioned really low numbers for pesticide usage across these countries. I was wondering if by pesticides you were including herbicides there, and also in that. So, first question is, what is the trend going on with herbicide usage in these areas? I've seen signals. I don't know the numbers, but I've seen signals that suggest that herbicide usage is becoming a lot more popular in Ghana. I've talked to some people in that regard and just seen some media stories about that. So I just wanted to be curious about that. And then also, are there any implications for herbicide usage in the context of fall armyworm, for example, if it's it feeds on 80 different plant species, is there possible effects from interaction effects?
So Ghana is a little bit of an exception. It is one of the countries that has higher pesticide, including herbicide use in Africa. And so the countries I mentioned, Malawi, Mozambique, and Namibia, sort of fall out of that. It's hard to generalize. But those figures that I quoted do include herbicides. So herbicides are not used much at all in smallholder production. Certainly if you go to larger commercial production, or even if you go to vegetable production locally that might have a higher value, those people will, because they are producing for the market, and they'll make a little bit of money. And so they will use the pesticides on those crops. So it's very specific per crop and also by country. In terms of the use of herbicides on fall armyworm, it's a great question. Certainly, fall armyworm lives in the weeds around, but I don't think the farmers are probably going to be using the herbicide in all those, it's so heterogeneous. There's a little plot of land, and there's a vacant area, and there's some trees, and there's some weeds, and they probably won't be even using the herbicides in all that other area, weedy area, but they probably does harvest some fall armyworm. Okay, so Jason, you have a question?
Sure. So I was really struck by your talk of how open you are in this presentation to all these different kinds of methods of control. You're mentioning things that you're not even sure if they work, but you're kind of respecting and honoring the diversity of approaches here. I'm curious, is that a reflection of who you are in terms of your priorities and understanding? Is that a reflection of FAO's development over time of understanding the benefits of local practices? Or is this unique to this particular case? As you argued, people aren't using pesticides, using expensive inputs isn't going to solve this problem in Sub-Saharan Africa because it just won't make economic sense. Or is it some combination? Because I'm just really struck by the fact that the takeaway message here is there's lots of things to try, and it's probably not anything about high-tech or pesticides, or you mentioned biotechnology, but that would seem to be off the table if run-of-the-mill pesticides aren't even available.
So it is all the above, my answer. Part of it is who I am. Most of it is what FAO's experience is and what FAO is. So FAO, part of the United Nations, we have 195 member countries. They decide what we do and how we do it. That's not easy, 195 countries. So we're not going to typically go very strongly in one area. But then third and probably most important though is actually the possibilities for these farmers. So I did mention biotech. I mentioned the GM maize that used for fall armyworm in the Americas, here in North Carolina, in Brazil. But the reality of those farmers, which I try to get across in a fair amount of detail, is so different, so constrained economically, that those options are not on the table for them. On the table, South Africa uses GM maize. Those large commercial farmers have GM maize and they use it. And they're using it for fall armyworm right now. Syngenta has brought it in, and it's working. But so it's all of the above, and also because it is new, and we're still in the exploratory stage. And there certainly is no silver bullet, which is obviously one of the points of my presentation, but also the openness about we don't have a solution. I mean, how can we have a solution for all of Africa? Incredibly diverse, continent, systems. Even though everybody produces maize all around, from humid tropics to highland dry areas to Ethiopia to deserts, we're not there yet. But the point is that there are lots of ideas and experiences that farmers in Central America and Mexico have been doing and using, and also that farmers in Africa have been using for a while. So let's do that. And then finally, FAO, certainly we've worked on this farmer field school approach for over 25 years. Something that we've been doing for a long time. I don't know if any of you have heard of. Peter Kenmore, 25, 30 years ago in FAO, started doing this in Asia and rice, working with farmers in their context so that they try things and see what works for them. And it goes back. It's interesting, in the United States, to IPM, how we bring these different components together. In the United States, we don't even talk about, or it's not talked about, foreign IPM anymore, because we have this magic bullet solution of GM maize. So what we've also done, what I've also done personally, is to go back into the literature, like in the 1970s and 80s, when people were still using pathogens. And I took pathology, insect pathology with Wayne Brooks here many years ago, and he talked about the NPV for Spodoptera frugiperda, but we don't talk about that anymore because we've got this magic bullet. But the point is that there are many things out there that farmers are doing, also in the literature from the 70s and 80s, that we're trying to resurrect and try under local context.
Wondering about unintended benefits of the fall armyworm. Bear with me. So in small farm holders in Africa, there's huge loss post-harvest, in post-harvest storage. I'm wondering if the fall armyworm is, and there's solutions to this. There's technological solutions to this. I'm wondering if this pressure is causing farmers to try to save more post-harvest.
That's a good question, and I don't have any experience with that, or I haven't talked to farmers about that. But again, that's something in my brain that next time I talk to a farmer, I'll ask about.
Some of these estimates are like 50% of the stored crop being lost in storage to fungi.
Right. So one thing I certainly have learned in many years of experience is that those estimates are often exaggerated, and often dramatically so. So even with the yield loss to fall armyworm, you can read in other manuals for fall armyworm out there that it causes 70% yield loss. Well, it may have done. In fact, this is embarrassing. There's one manual out there that quotes 53% yield loss from fall armyworm. In fact, I know that study because Fred and I published that paper, and it was under a severe drought condition in Nicaragua when I was doing my PhD, and I did one of these studies to look at infestation levels, different times, and yield loss, and it was 53% in one drought season because it was the drought. I mean, it really wasn't falling. It was that combination of all that damage and evapotranspiration, and sure you get a big loss, but it's not typical. So I would say we have to all be careful, and people oversell the losses for many, many reasons, whatever they want to sell or whatever they want to promote. So I'm sure that there are important post-harvest losses. I don't want to say that, but I would be careful about throwing around those figures. But it's a good point. Are they now having to save more post-harvest because they haven't harvested as much? Good point. Yeah.
Are there any places where people are able to respond to the loss of yield in maize by just growing less maize? You mentioned most people grow multiple crops, so does the amount of resources devoted to maize just go down in places where there's an alternative?
So I think, and I have heard farmers talk about that, about growing more of other crops instead of maize, but they really do depend on maize as a staple in their diet. And so it's like saying, whatever your favorite staple food is, that you're not going to have as much of that anymore. It's really hard for them to get off of maize, because for the last couple hundred years, throughout Sub-Saharan Africa, it's become one of the dominant foods for many people. So it's hard to do that. But I have heard farmers talking about planting more of the other crops and other crops that they could eat off. I talked to one woman in, where was it, Kenya, and she said she's going to plant more potatoes in her fields than maize, exactly like that. So farmers, I think, they respond rationally to it. Yeah.
So in this sort of period of upheaval, you may have like these latent policy agendas in the background throughout these countries, maybe especially involving forces in the biotech industry and things like that. To what extent have you seen this issue been used effectively or ineffectively, or correctly or incorrectly, to sort of try to liberalize policies for GM maize?
Yeah, that's present in quite a strong way. Certainly the industry has been very active in responding and going back to ministries as well as some donors and say exactly that. You know, here's a crisis and here's an opportunity. So there's been a push to talk about GMAs as a solution. I think it hasn't gotten a lot of traction because of who those farmers are. I mean, if you're talking about trying to introduce GM crops in, well, the debates that were held in the US a long time ago, you have clients ready to use it. But in Sub-Saharan Africa, how are you going to, first of all, do that? And I think the companies also know that for maize, there's not much business there. They're not going to sell, they're not going to all of a sudden start, first of all, how would they do that? Move the genes into all these different varieties, locally adapted, then the distribution system and getting the seed out there, and then the cost of it. Farmers can't afford it. So I think in the background that's understood, but certainly there has been a bit of undue enthusiasm to say that, listen, you know, if you just changed your law about use of GM crops in the country, this would be a solution or one more tool in your toolbox. And so there's been a lot of promotion of that and use of it. It's okay. It's a healthy discussion about whether or not that is an effective tool in the toolbox that these farmers could use. So it's talked about.
You mentioned the different varieties. I'm wondering, are there differences in resistance to the pathogen or maybe palatability? And since there's kind of a grand experiment potentially going on there and other people could adopt varieties that were better?
Yeah, so that's a great question. I've heard reports, or we've heard reports, people say, oh, there's this local variety that seems to be really resistant. But you hear those kinds of stories all the time. And then when of course I mentioned it to Prasanna, who some of you may know, he's the head of the maize program for CIMMYT worldwide, based in Kenya. And he said, no, there's no resistance out there. That's all just hearsay. It's what the farmers talk about. But I don't know. It'd be wonderful if somebody would do that experiment, collect some of these different varieties, or go to the farmer reports and get some and do the experiment. It's another very neglected area of work that nobody does any work on. So could be.
I'd just say to that point, if you're collecting the data of damage to the laurel or leaf, I mean, it seems like if they're documenting the strains of corn, that is measurable.
Yeah, no, you're right. If we get enough of that big data, so when we have 1 million or 100,000 data points in our system, and we have that data, infestation levels and variety, we should be able to tease that out and get some indication at least which ones we should go after to test.
Talk a little more about what that 10 to 12% yield loss means to like a smallholder farmer. I mean, numbers-wise, it doesn't seem like that's a big loss, but what does that actually mean for sort of a smallholder farmer that only has a
Yeah, that's a great question. And that's been subject to a lot of discussion and debate, because people say, okay, so that's going to, if the tipping point, or could tip them into food insecurity, if you have 20% yield loss, and you're dependent on that to feed your family, that's very significant. And it could be, especially if you're right there on the margin. And I think many farmers are right there on the margin, but I think they're also on the margin because they've kind of figured it out over time, how much maize I have to plant to feed my family. In fact, if you ask, and I've talked to many of these women, and they'll tell you, they'll know exactly how much area they plant, and that's what they're doing. They're planting the area of maize that they know they have to harvest to feed their family. So whether or not they'd be able to increase that production by other area, I don't know, or denser planting, I'm sure they're thinking about that, or not. are there limitations they run up against in terms of area to plant, in terms of resources, and that would tip them into food insecurity? That's a great question.
When you talk about biotechnology as a possible tool, you've gone along the model of industry being involved. What about the model of what's happening in Bangladesh with eggplant? Is that a possibility in Africa?
So,
with corn?
Yeah. So in fact, the Gates Foundation and industry is supporting AATF, the African Agricultural Technology Fund, which is an NGO. It's very much supported by Gates and industry, Monsanto, or Bayer now. And they've been working on transgenic maize with the hope, with the idea of, giving it out to people for free, and talked about paymentless royalty license approach, etc. So it's been explored by others, and hopefully it'll move forward. The real question is how, again, do you think in great detail about getting that into and used in a sustainable way, resistance management, etc. In Africa, there are many, many hurdles to get over. I'm not saying it's impossible, but I think it is being done by the Gates Foundation and by the AATF. So they'll continue to explore that. And they're working with certain governments. They have permission from Kenya. They're doing small trials, field trials, of their transgenic maize.
Any questions from anyone who hasn't asked a question?
Just a question about these data collection with that instrument. And who do you expect to really be sending you the data? I mean, what's your expectation for that in different countries and so on?
So our experience to date is that it mostly depends on if a government or a country adopts it as its official system. I was telling you some of it just before. I didn't show the map, but I can show you. Actually, it's online. I could give you the link. And the best data we have, all the countries, well, it's not even Africa, the best data we have of any country is from Yemen. You're going to say, what the heck? War-torn, poverty country. Why do you get data from Yemen?